Okay, so this is the beginning of the review for the chapter number 6, okay? This is the first half. I'm going to break it into two videos. Write a ratio of miles to days, and you'll see that's 50 miles to 10 days is the units we would use. And so we stack it up, 50 on top, 10 on bottom. Use your fraction box on the calculator to simplify it if you need to. You know that that would equal a 5, but it's a ratio. It needs two numbers, so just slide a 1 under there, and you're ready to go. That's your answer. If you label it, that's okay, but you don't have to for ratios. Number 2, days to seconds. So we would put 10 over 3 there, and 10 over 3 does not simplify, so we're done, okay? But you still want to use a fraction box in the calculator to check that. Okay, so you're not dividing, you're using the fraction box there for ratios. For rates, it's the exact same thing, but you have to make sure you label this time. You can't leave the label off, you have to do it. And so just like we said on number 1, you could label those if you wanted to and it wouldn't hurt. That'll save you from wondering if you need to label it. Just go ahead and label it if you're wondering. So miles to seconds, that'd be 50 over 3. Stick that in the fraction box, and it does not simplify any further, so you just go ahead and label it 50 miles over 3 seconds. Write a rate of miles to days, and that would be 50 miles over 10 days. That does simplify that down to a 5, so stick a 1 under it, and don't forget to label miles to days. For unit rates, the beginning setup's the same, but instead of using a fraction box, we'll use division. So miles to hours would be 50 on top and 5 on bottom. What you do is you take the top number 50 and divide it by the bottom number 5, and you get 10. Again, it's a rate, same as a ratio, so you need to have two numbers there. We'll just slide a 1 under it, and don't forget to label. Okay? So remember, all that a unit rate is a 1 on the bottom, and you can always get that by taking the top number and dividing it by the bottom. Number 6, it's miles to seconds, so it'd be 50 miles over 3. So we're going to stick into the calculator 50 divided by 3, and we get a really long decimal there. And remember, unless I tell you otherwise, we need to round it down, and for right now, we're just going to say to the nearest hundredth, so that'd be 16.67. But stick a 1 under it and label. Now, number 7, how many numbers does a ratio have? 2. That's the reason. Back here, like when we got one number after we divided, we had to stick a 1 under it so we'd have two numbers. So how many numbers does a ratio have? 2. And then what math operation compares the numbers in a ratio or rate? It would be division. Now, a car travels 8/3 of a foot in 1/3 of a second. Make a unit rate of feet to seconds, and it tells you right there feet to seconds. So we're going to take 8/3 feet because that's our feet, and we're going to stick that over the seconds, 1/3 of a second. And how do we make a unit rate? We literally just take the top number, 8/3, and we divide it by the bottom number, 1/3. Same way we did for number 6 and number 5, right? Top number divided by the bottom number. And we will get a number. In this case, it's a whole number. It's an 8. And we're going to stick that over a 1, so that way it's still a rate there. It takes two numbers. And don't forget to label. It'd be 8 feet, 1 second. Number 10, how far can a snail move in 1 minute? If the snail moves 1/20th of an inch every 1/2 second. Well, it's asking you all about how far can it move in 1 minute. So we need to come up with how many feet that snail can move in 1 minute. The problem is that they gave us 1/20th of an inch for every half second. So they're wanting minutes and they're giving us seconds. But you know what? We can take what they give us, a 1/20th of an inch over 1/2 of a second. We can take what they give us and we can say, hey, take the top number 1/20th, divide it by the bottom number, and we get this weird fraction, 1/10. Well, that's how many inches it can go in 1 second. That's a unit rate, right? So now I know how far the snail can go in 1 second. And that's kind of nice, but how far can it go in 1 minute? I know how far it can go in 1 second. That's what they gave us. We made our unit rate. Well, think about it. 1 minute's the same as 60 seconds. So if I know how far that snail can go in 1 second, can I take that 1/10 and times it by the 60? Sure I can. Type that into your calculator and you'll instantly see it's 6. So how far can that snail go? That snail moves 6 inches in 1 hour. Not very far, but then again, it wasn't moving very fast at a half a second, was it? Now, how far could a person jog in 1 hour? if they ran 7/8 of a foot every 3/4 of a second. See the difference there? They're asking us about how far I can go in an hour, but they only gave us, how far I can go in a second or 3/4 of a second. So we're just going to start with that second stuff. It's 7/8 of a foot over 3/4 of a second, and we can make a unit right there. So 7/8 divided by 3/4 is going to get us a fraction there, and that is the number of feet, and we need to stick a 1 under it. So that's how far this guy can go in 1 second. So every 1 second he jogs 7/6 of a foot. We're nowhere close to how far he can go in an hour, but I know how far he can go in 1 second. So how far could he go in a minute? Well, 1 minute's the same as 60 seconds. So how about if we take the 7/6 and times it by 60, and we get 70 feet for 60 seconds, okay? Now, I know that 60 seconds is the same as a minute. So basically, every minute, this guy or girl can jog 70 feet, not going very fast. Could I figure out how far to go in an hour? Well, sure I can, because if he goes 1 minute every, 70 feet every 1 minute, then think of that as 60 minutes for an hour. Instead of 1 hour, just think of it as 60 minutes. So take that 70 feet and times it by 60, and we'd get 4,200 feet. So as a recap, he could jog 4,200 feet in 1 hour. And we started out with 7/8 of a foot divided by 3/4 of a second. We made that into a unit rate, so then we could figure out how far he'd go for 1 second. After we knew how many he could go for 1 second, we times that by 60, and we knew how many feet he could go for 1 minute. And then after we had how many feet he could go for 1 minute, we times that by 60, and we got to 4,200 feet in 1 hour. Number 12, a pot of soup containing 30 cups of water. So let's just go ahead and draw that pot of soup there. Let's dump in the 30 cups of water. It's got 5 cups of chicken and 5 cups of noodles, so let's draw in the 5 cups of chicken and noodles. Doesn't really matter what order, as long as it all goes into the same pot. What percentage of the soup was chicken? Well, we got 5 cups of chicken. What goes on the bottom? The total. So you add up everything that's in that pot. 5 plus 5 plus 30 is 40. So 40 cups goes on the bottom of that fraction. 5 divided by 40 is 0.125. So it's 12.5%. The soup was 12.5% chicken. 13, hot chocolate. Used 1 cup of chocolate and 5 cups of water. What percentage of the hot chocolate was water? Let's dump in our 1 cup chocolate and our 5 cups water. And let's think about this. It's interested in what percentage the hot chocolate was water. That'd be 5 cups, water on top. And how much is in the hot chocolate completely? Well, 5 plus 1 is 6, so 6 goes on the bottom. We always want the total on the bottom for this type of problem. So now we can divide the fraction. 5 divided by 6 equals repeating decimal. Slide that over twice to make it a percent and round it. Let's just round it to the nearest tenth here. 83.3%. Okay? Unless I tell you specifically on the test, as long as you get me in the ballpark, 83%, 83.3%, 83.33%. Maybe you don't round, you just stick all those threes on there. If you're in the ballpark, I'll give it to you, unless I tell you how I want you to round. So that's the first half of the review. Every single problem worked out, and hopefully you're looking at your paper and agreeing with this.